Hello, Calculus BC students. This is our last video review before the AP exam. I want to go over the Calculus BC super free response question number 3 that I posted earlier this weekend. And I thought this was a good question because a lot of the topics here you struggled with on our last practice exam. So I thought it was good to review. So let's walk through this. All right, all these questions deal with a family of functions f of x equals 1 over x squared minus 4x plus k, plus where k is some constant. All right, to start with, assume that that k is negative 12, find f prime of x, and the equation of tangent line at x equals negative 3. So uh, plug in negative 12 for k, and this is your function. Do the derivative with the chain rule, and you get this, which comes down to here. And then you plug in negative 3, and you get the slope of the tangent line is 10 over 81, and plug negative 3 in the original function to get the point, and then just do your point slope form for the equation of tangent line. All right, pretty straightforward there. B, assuming k is negative 21, find the integral of f of x dx. Okay, so this integral becomes 1 over x squared minus 4x minus 21, which we need to write as partial fraction expansion form. So that's what I'm going to do on the side here. I'm going to factor this as x minus 7, x plus 3. So it'll be a over x minus 7 plus b over x plus 3. And remember how we do this algebraically. We multiply both sides by the LCD, so we get this. And then you choose values for x to plug in to solve for a and b. Plug in negative 3, a goes away. You solve for b is negative 1/10. Plug in x equals 7, and the b term goes away, and you get a equals positive 1/10. So back to integral then, you can write it as this integral. 1/10 over x minus 7 minus 1/10 over x plus 3. And then you do the antiderivative, and you get this, and you don't have to, but if you want to, you can combine it into a single logarithm. Subtraction becomes division, so you get that as your answer. So that's an integration with partial fraction expansion. All right, another integral, assuming k equals 4, find the integral 0 to 3, f of x dx, or explain why it does not exist. Okay, so you plug in 4 for k, and you can factor that denominator. It becomes x minus 2 squared. Notice that means the graph has a vertical asymptote at x equal 2. So because my integral goes from 0 to 3, 2 is an interior point of that interval. That means that we have an improper integral. Improper integral. So I'm going to set up as two different integrals. The first integral from 0 to 2, plus the second integral from 2 to 3. And then each of those I take a limit. Then I replace the 2 with the b, and the first limit as b approaches 2 from the left, because b is the right bound of this. And then replace the 2 with the a. Limit as h approaches 2 from the right, because a is the left bound of this. And then you do the antiderivative. All right. And plug in your b and your 0 and your 3 and your a, and you end up with these two limits. And what happens here, if you plug in 2, here you get 1 over 0. That means there's a vertical asymptote at 2 and a vertical asymptote there at 2 as well. So both limits are undefined. Both limits are undefined, which means that the integral diverges. That integral diverges. Okay. Part D. Find all values for k so that the slope of the tangent line at x equals negative 2 is equal to 2. So I plugged in set it equal to 2. You take the derivative. You want the derivative equal to 2, right? Because it says the slope of the tangent line at negative 2 equals 2. So I take the derivative in terms of k, right? My k stays inside here. Take the derivative, say equal to 2. And I'm going to plug in negative 2 for x, and you get this equation here. 12 plus k squared equals 2. And then multiply and divide, and you get 12 plus k squared equals 4. Square root both sides. Don't forget the two answers, right? Don't forget to put the plus or minus 2. And then you get two answers for k. Negative 14 or negative 10. Negative 14 or negative 10 are the two answers. All right, last one. Assume k equals negative 5 and g of x equals that function. Find limit as x approaches negative 1, f of x times g of x. All right, so there's your f of x. And when I multiply it by the g of x, I end up with this limit as x approaches negative 1 of this over this. Okay, so we're guessing we might have to do L'Hopital's rule, but let's double check. Plug negative 1 in the numerator and you get 0. Plug negative 1 in the denominator, you also get 0. So there you go. The limit of the numerator and denominator are both 0, so we must use L'Hopital's rule. So now, use L'Hopital's rule, take the derivative of the numerator, and we get this. Don't forget the chain rule, multiply by 3. derivative of the denominator, we get this. And now I plug in -1 and I get -5 over -6 or 5 over 6. All right, so that is your um, free response question number 3 I gave you to work out. All right, so there's another free response question I posted. If you want the answers for those, email me and I can send you the work that the author did on those. And then over the weekend, I posted a link to some videos on YouTube from other teachers doing practice problems, so you can post those or you can work on those as well. Um, and let me just say a couple things before the exam on Tuesday. My suggestion for the exam is that you have all your paper written out with your APID and your initials on the top, and then write out question 1. Put part A and part B. Leave plenty of room. Leave, I would say, half a sheet of paper. Do part A, part B on one paper. Then do the second paper. Put question 1, part C, part D, and do the same thing for question 2, part A, part B. And that way you have room to work. And the exam starts, you can just sit down and write out your work. And also, don't get too bogged down in one part of a problem. If there's 5 or 6 parts of a problem, if you get to, let's say, part C is difficult, skip part C, move on to D, E, and F, and come back to part C. Okay, and that's why it's good to have your paper already labeled. If you get halfway through part C and you stop, you can skip down to part D, work on that, and when you go back, there's already room on the paper there to finish part C if you want to. Okay, so uh, just keep doing plenty of practice problems over the next day here, and I'm sure you'll be well prepared for the exam on Tuesday. Okay, so I'll be thinking of you during the exam tomorrow. Good luck to everybody. Bye bye.